Hi everyone. Thank you for the introduction. So this topic is gonna be simple. If most of you have already, you already know about containers, and you'll be also knowing about CI/CD. So how many of you here use CDK? Okay. Okay, cool. So I see only one. So, so this topic is going to be about automating CI/CD deployment using CDK. I'm not going to be explaining the whole code, but I'm going to be giving you the project link towards the end of the session. So, about me, I'm cloud engineer 2 at Mastery. I'm a community builder under containers category. I'm a recent graduate at IIT Kottayam. So, I'm actually rushing to here after my graduation ceremony. So, let's talk about like we already discussed about containers, but I'm going to be running you quick through how or why we should use containers. So if you are a DevOps or like a cloud engineer at your company, you might be already uh, dealing with devs or like the dev request asking to you to like write Docker files for your application, like for their application. So when the like application demands increase or like when the resource utilization increase, we could turn towards containers. Like containers, as you can see, it can make the performance consistent, and like it can make it easy to port your application across environments. So like let's say devs are working on their local or like it's spread across, right? It's not like a single person working. So it's mostly spread across different environments. So some might be using Mac, some might be using Linux, Windows. So containers make it easy and consistent to uh, measure or like take the exact performance of your application. And then we have the efficient resource utilization. It's lightweight, of course, and then it's easy to scale. Like if you're using like let's say ECS cluster, for example, you can easily like horizontally scale up. So if you want to vertically scale up, that's possible too, but you might need a redeployment there. And then like containers are easy to like you can easily do like start and stop the containers easily. And also of course you have Docker images. So each of the images have image tags, which makes it easy for you to roll back in case you need a rollback support. So like of course these are some of the few points you could uh, think of why you should go for containers for application. Next, so I saw only one of you guys knowing about CDK. So CDK is like yet another infrastructure as code tool. It's supported by AWS team. So it's an open source software development framework that helps you define resources using infrastructure as code in like multiple languages. It's not limited to for example, Terraform is like written only in HashiCorp language. So instead of that, over CDK you can go through like JavaScript, TypeScript, Python, Java, .NET, and Go. So CDK basically provides you infrastructure construct. You can see the example over there. So the lambda dot function is a construct. So you just give these values. Like it's just straightforward. If you look at the like that screenshot over there, you'll be easily getting the concept. Like you don't need to know a lot of technical or coding stuff to get no, I mean understand this. So you can just see the runtime. Like what's the runtime you need for your lambda? It's just node 18.18x. So it's as simple as that to define your resources using CDK. So even if for like the constructs that are not there, you could use custom resource. That's another feature supported by CDK. So as you may know, you all of the API calls, all of the clicks or like infrastructure provision all happen using API calls inside AWS. So if you want to make a custom resource, it's basically using the same API call to set that like API call and give the values it needs using CDK. So you can even create custom resources for infrastructure construct that are not natively supported by AWS. Okay, so now let's go to why we should automate containerization. So containerization, as I said, it helps you to, uh, you know, scale up or like improve the performance of your application. It can improve the performance of your application depending on the application. So now if you are to automate containerization, it first of all makes it easy to deploy because you don't need to manually like you don't need to manually get involved to see like if the health checks are working or stuff like that. If you once you set up the process, it will just go through its workflow. So that's one point. And then going on, we can minimize the downtime. Like if you are releasing a new change to your application to prod, so how do you minimize the downtime? So if you are to like stop your instance or like without the right strategies, it can cause downtime. Like you might need a potential downtime window, stuff like that. But if you use the right strategy, like a linear deployment or like a blue-green deployment, stuff like that, you can minimize the downtime by setting the like replacement task ready and gradually or linearly uh, shifting the traffic to your new containers. Okay, so that's the second thing. And then consistency across multiple environments. So let's say if you have a multi-account architecture, like you have like a QA, stage, prod, stuff like that. So if you want to make it uniform across all your environments, so automation makes it really easy for you to, you can have a single version control system, and then you can, once you build your image, you would be deploying the same image across all the environments, right? So you can gradually take it over to your prod, like after the QA testing is done. So you can make sure that it is consistent across all the environments. Okay, so the next point is reduce human errors. Of course, like once it is automated, there is no scope for like any human misconfiguration, like something that can go wrong within the workflow. So once it is working, it's working. So that's that. And then the flexibility to control deployment from version control system. So if you have like GitLab or GitHub as your version control system, you can set up triggers or like set up ways to automate the deployment from your version control system. I'm going to be explaining that in a while using the architecture diagram. And the next is rollback support. So if you're using like code deploy, for example, to automate your container deployment, you have the support for rollback. So based on you like services like that, you can always have the rollback support. Next is the security and compliance. Using the health checks, like I said before, you can make sure that the application is working as expected, like if the processes all start and are not shut down like without any warnings. Okay, so how do you automate the deployment process? So like how many of you know about code pipeline, code deploy, and all those stuff, code builds? Okay, cool. So some of you might have already been using this. So the architecture is really simple. If you know a code pipeline, how code build and how code deploy works, this is going to be really simple for you guys. So like the idea here is having two repositories. So if you have GitLab as your version control system, you might already know that there is no native integration. I mean, there was no native integration to AWS until recently. So recently, AWS introduced support for GitLab as source for code pipeline. That's not a supported source for code builds, but it's a supported source for code pipelines now using CodeStar connection. So but there's another drawback for that. It doesn't support Git tags. So if you wanna, uh, control how your code pipeline works with the version control system, a recommended way for using GitLab as source is using code commit repo, so that your code is mirrored into code commit, and you can control how the pipeline works from there. So the top side repo diagram, repo part is regarding the application. So that's where the Docker file of your application will sit. Once you have all the Docker file and all the application ready to go into your environment, you can just add a tag like this. This is something yet another interesting thing. So if you wanna maintain consistency across your images, you can use a proper naming convention for your images. Like let's say something we follow, like my company follows, is called tagging the images based on RC. RC stands for release candidate. So RC-1, RC-1.2, 2.2, like that. So it makes it easier for you guys to understand what the image stands for. You can also add a description when you add tags. So it makes it really easy to track down what was the previous version compared to what's going on next. So once you add a tag, you could push this to code commit using a CI or using code mirroring. So code mirroring is a feature supported by GitLab to push or like mirror the code what you have on GitLab to AWS code commit. So once you set that up, you could you know replicate what's on your GitLab to your code commit, and you on the code commit you have a lambda as a trigger. This lambda will be looking for the tags, like it will be looking for reference updates or like tags which are coming into the code commit. So based on that, the lambda will be triggering a build. So the lambda is the one which is responsible for triggering the application build. The application build, of course, it goes through the whole process what you have defined in the Docker file. Once the application build is ready, it pushes it to ECR. So ECR is where your application code will live. Like I said, if you have proper naming convention, it will not rewrite the old images, and you won't have to be worrying what was the previous image. If you have proper naming convention, all the versions will be listed there, so you can easily roll back in case of any needed support. So the image is on ECR right now, and the second one is the GitLab repo for ECS. So the ECS cluster right here will have an appspec.yaml and task definition.json. So the appspec.yaml will be responsible for the code deployment. You'll be just mentioning the task definition version over there. That's a variable which will be written by the first code build under the code pipeline, and the second one will be task definition.json, where you will specify what the applications are like, what the resource limits for your task should be like. You will define the memory, you will define the CPU limits, you will define what all variables the container needs to access, stuff like those. You will also define if you need any EFS volumes, if you where the logging should go. All those stuff will be defined in the task definition.json. So once that's done, you'll again push that to code commit, because of you need to have proper control over how you should start the code pipeline. And these two, like the code commit for ECS GitLab repo and the ECR image, both of these will be the source for your code pipeline. So once you're ready to push your image, whatever image you need to like your environment, so you just start the pipeline and then it will continue. So first of all, we'll create the task definition. Like I said, the task definition will have a variable which is the latest task definition number. So it will be dynamically increasing. Like I have the code in my GitLab. I'll be showing it after this page, so you could refer that for more insights onto how it works. So the task definition and the appspec.yaml will be filled with the necessary information. Once that's ready, the second code build will create the code deployment. So this code build is just so if in case you have a multi-account or like cross-account architecture, like you run all your pipelines and stuff in one account and you deploy all your applications into another account. So you could have stuff like that, like a like setup like that, where you assume your credential for your workload account and then deploy your application into there. So if you do not have a cross-account setup, you could just avoid the workload account part over there and just continue deploying. You don't need the code build over here. Instead, you could just use the code deploy. Okay, so the code deploy over there will be responsible for spinning up the new container, doing the health checks, making it ready until you're ready to shift your traffic. So you can set up a window of time until how much you want to wait till you route your traffic to your new task. So code deploy takes care of that. You can also define how you want to shift your traffic. Like I explained previously, you can set up blue-green deployment, and you can set up linear or all at once. There are multiple options via which you can route your traffic. So once that code deploy is ready, like the container, the code deploy confirms that your task or like the new container is healthy and it's not crashing often. It will be like the code build over there will go into like success rate. So it will finish that and wait for a manual approval step. So this part right here is really important for in case of any rollback, or if in case you need to have proper control over what goes into production. So that part over there, like I said, the code deploy is ready to shift traffic to your production container. So once you approve that, there's another code build which just assume back to the workload account, and then it continues the deployment, meaning it routes the traffic for you. So any doubts in this architecture? Okay, so yeah, basically that's the entire flow. Starting from, I'll just quickly go through it again so that you guys can have a recap. So first we have the application repo, the code commit have a Lambda trigger. So the Lambda trigger will build the image and push it to ECR. The second one is the ECS GitLab repo, which has the task definition.json and app spec, which is needed for the code deploy to create the deployment group. And both of these will be the source for your code pipeline. The code pipeline has 3 code builds. First one for creating the task definition. It will just populate the task definition with accurate task definition value. It will be a number which gradually increase so that you can keep a track of the task definition versions. And the second one is a code build which creates the code deployment. So this will be responsible for spinning up the container, doing the health checks, and make it ready to shift the traffic. So the last code build, once you do the manual approval, it will just route the traffic to your new container. So yeah, that's it basically. Any questions, if you have, you can feel free to ask. This is the project link. If I have given a rough template of how the pipeline would look like. Thanks everyone. That was my first session as a speaker. So
Thank you, Vishnu.